distinguishable and indistinguishable boxes. Ayan. Okay, go! Sige, habang kayo nandyan, kukuha lang ko ng tubig. Okay, start na tayo. Mag-ready na rin pala yung next na group, no? Kasi ito na yung last group 3.
Distinguishable objects. So, well, what do? We could think of possible combinations to divide 4 employees into 3 indistinguishable offices. So, the first one is when all of them are inside an office. So, we have A, B, C, and D here. And the second case, we could think of 3 of them at the first office and another one is in another office. So we have A, B, C, then D, A, B, D, then C, A, C, D, then B, and B, C, D, and A. The next one, we could think of 2 of them dividing 2 of them in the first office and the 2 of them are in the second office. So A, B, then C and D, A, C, then B, D, A and D, and then B and C. So yeah, 3. Then next one is all of them using all the 3 indistinguishable offices with 2 of them in one office and each one would be in another office. So it would be A, B, then C, then D, A, C, then B, then D, A, D, then B, then C, B, C, then A, then D, B, D, and A, then C, and C and D, then A, then B. So, another thing is we could use Stirling numbers of the second kind, which we could let S, parentheses, and J denote the number of ways to distribute n distinguishable objects into the J indistinguishable boxes, where boxes are non-empty equals K. So, the problem would require us to distribute 4 employees to 3 indistinguishable offices. So we have S for 3, in which according sa nilista natin dun sa possible combinations, we have 6 possible ways. Then 4, 2 equals 7. 7 because, diba, when it comes to distributing 4 employees into 2 offices, we had the case where 3 of them are in the first office, then another one in the second one. Then we also have this scenario where we could have 2 of them dividing the offices equally. Then S for 1 is only 1, so it means 4 of them are only occupying an office. So 6 plus 7 plus 1 is equals to 40. Next, indistinguishable objects and indistinguishable boxes. How many ways are there to pack 6 copies of the same book into 4 identical boxes where a box can contain as many as 6 books? So in this type of problem, since they're all identical, we can't really differentiate them from each other. We can only enumerate them. So it could be at all 6 boxes are in one box, or 5 books are in one box, then only 1 book are in another box. We could have 4 books in one box, then 2 in another box. Or we could have 4 of them are in one box, 1 book in another box, and 1 book in another box. We could also have 3 of them in one box, three of them in one box and three of the books in another box. We could also have three of them in one box, two of the books in another box, and one book on another box. We could have three books in a box, then one in another, and one book in another box, then one book in another box. Then we could have two boxes on three identical boxes, two books in three identical boxes, and we could have two books in one box, two books in one box, then one book in a box, then a book in a box. So yes, so therefore 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 ways to pack these books into 4 identical boxes. So the last topic for group 3 would be generated permutations and combinations. Sometimes permutations or combinations need to be generated, not just counted, because there are questions that demands more than the number of possible combinations or permutations to arrange objects. For example, if out of all these possible routes to arrive at a certain destination, we have to determine the shortest path to that destination. Those kinds of problems would require us to generate and not just count the ways, the possible combinations and permutations to arrange objects. So in generating permutations, we have the first problem. What is the next permutation in lexicographic order after 3, 6, 2, 5, 4, 1? Lexicographic order is like arranging numbers in like a dictionary manner. Like for example, if you look at the dictionary, you always see that A always comes first before B, C, D, and to Z. But when it comes to numbers, the first number would be 1, then 2, 3, 4, 5, etc. So in this case, the next permutation is 3, 6, 4, 1, 2, 5. Why? Because the last pair of integers A sub j and A j plus 1, where A sub j is less than A j plus sub j plus 1 is A sub 3 is equal to 2 and A sub 4 is 5. So we could see here the third number is 2 and the fourth number, j plus 1, 3 plus 1, is 5. We could see that 2 is less than 5, therefore we could change the place 2 into number greater than 2 but still less than the other numbers on the right. So we have 5, 4, and 1. So between 5, 4, and 1, 4 would meet the requirements in the sense that 4 is greater than 2, but 4 is still less than other number, which is 5. So the 4 would replace 6, and then from 5, 2, and 1, the least number would be 1, then followed by 2, then number 5. So the next permutation is 3, 6, 4, 1, 2, 5. Generating permutations, another problem. Generate the permutations of the integers 1, 2, 3 in lexicographic order. So how did we come up with these permutations? So we're going to apply the concept of 8j is less than 8j plus 1 from earlier. So we have 1, 2, and 3, then 1, 3, and 2, because 2 is less than 3, therefore the places we have to swap. And since 3 is the only number there, so 2 we only have to swap with 3. So next is 2, 1, 3, which is 1 is less than 3. The numbers on the right of 1 is 3 and 2 is more than 1 but still less than 3. So 2, 1, 3. Then, since 1 is less than 3, the swapping takes place. So it would be 2, 3, 1. Then from 2, 3, 1, 2 is less than 3, and aside from 2, 3 is the only larger number, so it's number 3, then 1 as the least number, then 2, then from there, since 1 is less than 2, the swapping takes place, so it becomes 3, 2, 1. Generating combinations. The first problem would be find the next bit string after 100010010111, and the answer would be 1000101000. Because we see in the algorithm at below, we could see that while I is defined as 0, while B sub I is equal to 1, B sub I is 0, and I is I plus 1. So B sub 1 is equal to 1. So as we all know, when it comes to bit strings, when we add 1 to 1, it becomes 0, but the 1 would carry to another 1. And since 0, 1, 1 is kind of equivalent with number 999, the next number would be like 1000. There would be a great change where the 3 first numbers would reset to 0, and then there's number 1 at the last fourth number. So you can see that 1 becomes 0, and then the 0 became 1. Okay, the next problem. Find the next larger 4 combination of the set 1, 2, 3, 4, 5, 6 after 1, 2, 5, and 6. And the answer would be 1, 3, 4, 5. The last term among the terms A sub I with A sub 1 is equal to 1, A sub 2 is 2, and A sub 3 is 5, and A sub 4 is 6, such that A sub I is not equal to 6 minus 4 plus I, is A sub 2 is equal to 2. It means 6 minus 4 plus, if we add 2, if I is 2, then it would become 0. And it must be non-zero. So the 2 would increment to 1. Then, so the answer would be 3. Then set A sub 3 is equal to 3 plus 1 is equal to 4, and A sub 4 is equals to 3 plus 2 is equal to 5. Therefore, the next larger 4 combinations is 1, 3, 4, 5. Here is the combination. Here's the algorithm for the combination, where I is defined as R, while A sub I is equal to n minus R plus I minus 1. I sub I is defined as A sub I plus 1. For J is defined by I plus 1 to R. A sub J is A sub I plus J minus 1, which we applied the concept of how we got 1, 3, 4, 5 as the next larger combination of the set 1, 2, 3, 4, 5, 6 after 1, 2, 5, 6. And that's all. Thank you for listening to Group 3 and our report.
Okay. Ano may ginangata si Ma'am Pino? Ayan. Salamat, Monica.
Ma'am? Tapos na po.
Oo nga. Sabi ko nga salamat.
Sige po.
Okay.
Thank you po.
So, natapos na yung group 3. So, let's go to the next group. That would be Group 4. Ayan. Group 4, discrete probability and advanced counting techniques. That is chapter 7 and 8. So, Group 4, are you ready? Start na tayo, Group 4. Ayan na. Yan sila. Sound check muna.
Hello, hello.
Ayan.
Audible po, miss.
Audible na.
Yung ibang members, sound check ko yun.
Sound check yung mga members. Laksan ng konti.
Hello, hello.
Ayan. Better.
Mic check 1, 2, 3. Mic check 1.
Carlo.
Kinig po ba?
Yes, rinig.
Sige po.
Okay, start na.
Ayan. Good morning to everyone. We are the group 4 and we're going to discuss discrete probability and advanced counting techniques, which are chapters 7 and 8 from the book. Next, please. And here are our list of topics or table contents that we are going to be discussed. Here are some key terms from discrete probability and introduction to discrete probability, probability theory, Bayes' theorem, expected value and variance. And for the advanced counting technique, there will be application of recurrence relations, solving linear recurrence relations, divide and conquer algorithms and recurrence relations, generating functions, inclusion-exclusion, and application of inclusion-exclusion. Next. And before we tackle those key terms, we are going to have some activity. Does any one of you are familiar about the card game of higher or lower? Magpipili kami random na volunteer na pwede mag-participate. Please open your mic na lang. Thank you. Pa-end mo na ng screen. Sige.
Okay.
Nakikita po ba yung screen?
Yeah.
Ayan. Let's play po.
So,
Black po ba yung screen, miss?
black yung screen.
Wait po.
Meron lang silang ina-address na technical problem.
Ayan po, miss.
Black pa rin.
Black pa rin.
Mm-mm. Pero may puting guhit sa side. Pero yung loob is black. Ano nakikita nyo? Anong nakikita nung iba?
Clear po, ma'am. Itim yung background.
O, same yung background. Okay. Siguro, try mo dun sa sharing option. Baka kailangan naka-full share. Ayan. So, nakikita namin.
Okay na po, miss.
Okay na.
Ayan. Ito yung card game na masyado na, yung iba for sure, dahil sinalaro nila whenever they have a deck of cards. Mag-choose lang kami ng random person, then more on hula lang talaga kung higher or lower. Pero syempre, gamitan natin siya ng concept of probabilities. Let's play. Ayan, meron tayong points, then bet ka lang kung gaano karami yung kaya mong iris na points, then higher or lower.
So, sinong maglalaro?
Random po kami, pili po kami ng person, then
Okay.
open mic na lang.
Go.
For our first person, si Taripe. Hello. Please open your mic po. Ayan. Meron tayong first card which is yung king. Then you have 40 points. How much yung bet mo for your next choice?
Walang digit na bet.
10 to 40.
Wow.
I think i-spread mo yan.
May nabanggit ka na ang bet mo? Points?
Yes, ano, 12.
12? Ayan. Higher or lower?
Lower.
Ayan, lower. Ayan, tamang lower kasi since wala naman na higher sa king, lower lang talaga. Ayan, for our next person. Si Batis Laong. Hello.
Opo.
Ayan, for our next card, anong bet mo?
52.
52?
Slower.
Aray. Tama naman. Lower. Go na sa lower.
G.
Go. Ayan. Ayan. Risk taker ka. Kasi tama naman yung probability. Yan. Then, for our next person, si Pargola.
Hello.
Ayan, anong bet mo for the next card?
Ilan pala? Siguro yung half na lang.
Half lang ng 104.
Tas higher.
Higher, let's see. Oh, tama. Ayan, good. Yes. Then for our next card, si Rotap. Hello, good morning.
Hello. Ano yan, King?
Higher or lower, then kailangan mo lang mag-bet based sa points natin. Then choose ka kung higher or lower yung next na card.
Lower, 156.
Hmm. Okay. Lower. And good. Then our next participant is si Gamilong.
Opo. Yung bet ko ano? Half lang.
Half ng 3, 1, 2. Ilan ba yun?
Mm-mm. Tapos ano?
Ayan. Anong higher, lower?
Higher.
Higher. Oh.
Oh.
And lower. Yan. Okay. Next participant is si Annalyn. And anong bet mo?
Ano lang, 12. Tapos,
12?
ayun.
Ay, ano lang, ranging from 39 to 155 lang.
Sige, 39.
Okay. Anong guess? Higher or lower? Higher? Tama ba?
Again, higher.
Ayan. Ayan, tama naman. Then, next person. Si Presyo. Hello.
Hello?
Ayan. Anong bibet mong points for the next guess?
Higher.
Bet mo muna. Ilan?
Max. 194.
Bubusin mo. Okay. Kaya naman, 92, 4. Higher? Tama ba? Tama ba, Paolo? Higher?
Yes. Sorry.
Okay.
Higher.
Yun. Nice. The next guess is si Tapia. Hello.
Hello. Morning.
Morning. Anong points?
Wait lang. 388. 88 lang.
88. And ranging from, 98 to 388 lang.
Ganun. Sige, 100.
Ayan. Higher, lower?
Lower.
Lower.
Yes, lower.
Ayan,
Diba?
tama. And good. The next is Rochelle. Federal ba?
Hello.
Hello. Anong bet? Ilang points?
100.
No,
Ay,
starting from
120.
122 lang.
Sige, 122. Tapos, lower.
Lower. Okay. Okay. Tama. Sire. And the next si temporal.
Hello.
So, ayan.
Ganun.
Yes. Ilang points bet?
Max.
Max. Good. Ilan? Higher,
Tapos, lower.
lower? And see sa last card.
Papatalo ko na.
Ayun. Lower. And see natin kung may price pa. Goods.
Boomerang.
And then, let's proceed na sa presentation. Umaga nagsugal ba tayo?
Oo nga naman.
Well, it's, presents the probability, concept of probability. And wait lang natin ma-fix yung presentation. And good. Next slide. And we will be tackling some key terms that are important in learning chapter 7, which is the discrete probability. Next slide. And let's take some look back where probability came from. The theory of probability was first developed more than 300 years ago when certain gambling games were analyzed. Although probability theory was originally invented to study gambling, it now plays an essential role in a wide variety of disciplines. Next. In computer science, it is a key tool that allows us to predict performance, to understand how delay changes with the system parameters, and more. In algorithms, randomization is used to design faster and simpler algorithms than their deterministic counterparts. Next. Now let's proceed to the important key terms that we will encounter in studying this chapter. Next, please. First term is experiment. It is a process of investigation from which results are observed or recorded. So, ano pong ibig sabihin ng experiment? It is an investigation, pero ang ini-investigate ay dapat ang result niya ay observable or recordable. So, ano ang mga activities na nag-illustrate na experiments? Next. These are like tossing a coin, that is an experiment. Then, picking a card from a standard deck of cards, or rolling a die or dice. Next. Also, choosing a ball from a container or drawing a ball in a lottery. These are some of the activities that best illustrates the word experiment in the probability. Next. Outcome. It is the result of a single trial in the probability experiment. Next. For example, in tossing two coins, what are the possible results in tossing two coins? Next. Pag dalawang coins ang tinotoss, possible na dalawang head ang lalabas. Then maybe head and tails, or it can be tail, head, or both tails. Next. They are all called outcomes. The next is the sample space. The set of possible outcomes of an experiment. It is usually denoted by the letter S. Pag sinabi nating sample space, mayroon itong kaugnayan sa last term na diniscuss, which is yung outcome. So, yung outcomes po is pag nakakuha ng isang possible result, outcome na yon. Pag sinabi naman nating sample space, lahat po ng possible outcomes. Next. So, in tossing two coins, yung mga all possible result niya ay head-head, head-tail, tail-head, and tail-tail. So, wala na pong ibang possible results. Diyan na lahat nakalista. Next. Pero, pag nilista natin yung lahat ng possible result niya, ang tawag yun ay sample space. Then next. Probability of an event, according to Laplace's definition, it is the number of successful outcomes of this event divided by the number of possible outcomes. So in finding the probability of an event, we use this formula. This is the formula according to the Laplace definition. P of E, number of elements in E, over number of elements in sample space. According to the Laplace definition, the probability of an event is between 0 and 1. To see this, note that if E is an event from a finite sample space S, then 0 is less than or equal to E, less than or equal to S, because E is a subset of S. Thus, 0 less than or equal to P of E equals E over S less than or equal to 1. Take note that the probability of an event can never be negative or more than 1. Ang mga magiging sagot probability of an event can be presented in three ways. can be fraction, decimal, or percentage. Next. Example. What is the probability of getting an even number in the experiment or rolling a die? Next. So, in this case, ang hinahanap po dito ay ang probability of getting an even number. So, ito po yung ating keyword. Next. Sa ating die, pag niroll natin, there are 6 possible outcomes. 1, 2, 3, 4, and 5, and 6. The even numbers are 2, 4, and 6. So, ilan yung number of ways natin na lalabas na even number? Merong 3. Then, ilan yung possible outcomes na pwedeng lumabas? There are 6. Next slide. Then insert it in a formula. P of E equals G over 6. So remember na ang answer natin ay lagi naka-lowest term. Next please. So the final answer is 1 over 2 or 1 up. Ayan. Next term. Probability distribution. A function P from the set of all outcomes of a sample space S for which 0 is less than or equal to P of X sub I is less than or equal to 1 for I equals 1, 2, and so on to N. And the sum from I equals 1 to N, P of X sub I is equals to 1, where X sub 1 and so on to X sub N are the possible outcomes. Next. So we have the following properties of a probability distribution. First is the probability of each outcome is from 0 to 1, which the equation 0 is less than or equal to P of X equals to X sub I is less than or equals to 1. So parang pinag-usapan lang natin yung regular probability ay dapat talaga ay 0 to 1 o yung kanyang probability. Hindi tayo pwedeng magkaroon ng 2 na probability or 200%. Kapag 0 yung probability, ibig sabihin impossible pag 1 ay certain. Then the next property is the sum of all probabilities of the random variable is equal to 1 or 100%. Pag pinag-add natin yung bawat probability, yung values ng random variable, ang sagot dapat natin ay 1. Then, the next term is probability of an event E. The sum of the probabilities of the outcome in E. Next, for the probability of an event E, the equation will be P of E equals to the sum from S, an element of E, P of S. Note that the uniform distribution assigns the same probability to an event that Laplace's original definition of probability assigns to this event. The experiment of selecting an element from the sample space with a uniform distribution is called selecting an element of S at random. Then the next presenter will continue the key terms that will be important to be tackled on this chapter. Please proceed.
Sunod naman natin i-discuss yung conditional probability. Ngayon, ano yung conditional probability? Itong conditional probabilities is isang probability or isang probability of an event na kinuha sa isang sample space. At yung sample space na yun is isa ring probability event within the buong population. So parang kumuha tayo ng probability mula sa already existing probability or parang intersection ni E dun sa F. Yan. Para mas malinawan pa tayo, mag-proceed tayo dun sa example. Paki-next slide po, please. Ayan. Dito tayo sa example natin. What is the conditional probability that a family with 2 children has 2 boys, given that they have at least 1 boy? Assuming to na lahat ng probability is equal, na equal na yung probability magkaroon ng boy-boy, boy-girl, girl-boy, girl-girl. Tapos, yung pagkaka-assign nila, yung pagkakasulat nila, usually, yun yung nag-represent ng order kung paano sila pinanganak. Ngayon, paano tayo mag-proceed dito? Paano natin ito isa-solve? Una, i-assign muna natin yung events natin sa equation. Yung first event, yung aim natin is yung event na yung family with 2 children has 2 boys. Tapos kukunin natin siya mula sa isang sample space na already existing na probability, which is be the event the family with 2 children has at least 1 boy. So kukuha tayo ng probability na merong 2 boys within sa mga probability na merong 1 boy lang. Yan. At ito yung kakalabasan. Merong iisang laman na boy-boy dun sa first na sample space, first na probability event natin. Nasa sample space natin meron 3. Boy-boy, boy-girl, at girl-boy. So kung makikita natin yung intersection nila, yung similarity nila is yung boy-boy. So maiisip natin na yung kailangan natin dito sa equation na to, yung EF tsaka yung F ay yung 3/4 for sample space na yung sample space na pagkukunin natin, kasi meron nga tayong dalawang probability. Each probability meron dalawang possible option. So 2 times 2, 4. Yun. Merong 4 probabilities. So 3 out of 4, tapos yung intersection naman nila is isa lang. So magiging 1 out of 4. Tapos fraction division, 1/4 divided by 3/4 magiging 1/3. Yan. Ganun yung conditional probability. Next naman. Next po ng slide. Yan. Dito naman tayo sa independent events. Yan. Okay. Dito naman sa independent events, dalawang probability or dalawang probability events na nangyayari independently, hindi nila naapektuhan yung isa't isa. So kung kukunin natin yung intersection nila, magpo-proceed tayo kung paano tayo nagpo-proceed sa paghanap ng probability sa ibang ways, which is by multiplying yung probability nila. Katulad ng kunyari, pag kumukuha tayo ng probability na makakuha tayo ng isang buong deck ng cards na bubuo ng full suit. Dahil sa magkakahiwalay yung probability nila at hindi nila na-effect ng isa't isa, ipagta-times na lang natin sila instead na iba pa yung dagdag natin. Yan. So ngayon, mag-proceed tayo dito sa examples. Okay? Dito tayo muna sa same event or kaya same example as earlier. Isang family, children's, paano mangyayari? So, sa event E, dun sa first event, merong family na may 3 children na merong both nung sex. So, meron siyang boy at girl doon sa 3 siblings. Hindi lang natin alam kung ano yung number. Hindi lang nire-regard kung gaano karami at kung pang ilan. At sa second event naman, sa F, yung family at most has 1 boy. At most meaning 1 or 1 and below. Hindi siya at least, at most. So magiging isang boy lang or walang boy. Ngayon naman, paano natin siya mahanap? Paano natin malalaman kung independent ba tong dalawang events na to kung hindi sila nagko-coincide sa isa't isa? Saka natin gagamitin yung pagda-time sa kanila. Dapat yung intersection nila is equal pag pinag-times yung dalawang probability na ito. Ayan. Kunan natin yung value nila. Sa event E, ang mangyayari, magkakaroon siya ng 6 out of 9, ay 6 out of 8. Kasi nga, di ba, 2 times 2 times 2, 2 to the power of 3 since 3 children, tapos dalawang possible outcome lang naman. Ang mangyayari magiging 6 out of 8 kay E. Si F naman magiging 4 out of 8 which is 1 half. Ngayon, ipagta-times natin yun. 3 out of 4 times 1 half magiging 3/8. Ngayon, dapat equal sila dun sa intersection ng E at F. Kunin naman natin yung intersection ng E at F. Para pag kinag-compare natin si probability ni E sa probability ni F, makikita natin na meron tayong tatlong intersection. Meron tayong tatlong overlap. Yan. Kaya ang magiging 8. At makikita natin na equal naman sila. Totoo, equal sila. And thus, ibig sabihin independent yung events. Ngayon, okay, next slide. Meron tayong dalawang types of independent events. Yung pairwise independent events at saka yung mutually independent events. Yan. Ano yung pinagkaiba ng dalawa? Next slide po ulit, please. Okay. Dito muna tayo sa pairwise independent events. Intersection siya ng dalawang event. Only 2 events na ang similarity is adding yung probability nilang dalawa. So, independent event sila, pero only ng dalawang event. Kung makikita natin, kung paano siya, ninotate dito, lifted to directly sa book, yung nasa taas, yung, if probability of E intersection, E sub I, intersection of E sub J, is equals to probability of E sub I times probability of E sub J. Mapapansin natin, parehas lang siya ng kanina. Pero, tandaan natin na only 2 events lang siya. Kasi ito yung magiging mahalagang factor doon sa pinagkaiba nila. Ngayon naman, next slide po, please. Mutually independent events. Ngayon, dito na napapasok yung pinagkaiba nilang dalawa. Si mutually independent events, intersection siya ng 2 or more events. So, 2 or more siya. Independent event siya, pero pwede siya maging 3 events, 4 events, 5 events. Yan. Ganon yung difference nila. Si pairwise, from the word itself, pair, dalawa. Pero si mutually, hindi siya limited sa dalawa. Pwede siya maging 3 or more. Yan. Kaya kung makikita natin yung lifted na definition right out mula sa book, yan sa taas, these events are mutually independent if P intersection of, P, probability of E sub I sub J to the intersection of E sub I sub 2 intersection of ellipsis E sub I sub N. Kung makikita natin, hindi lang siya limited sa dalawa. Pwede pa siyang dumami ng dumami. Yan. At dito sa mutual independent events na to, saka papasok yung isa nating topic. Pwede pa next? Saka papasok yung yung isa nating topic. Pero bago natin i-discuss yun, ngayon, nalaman na natin yung difference mula kay pairwise independent event ay kay mutually independent events. Na si pairwise is only for 2. At si mutually naman ay 2 or more. Yan. Ngayon, doon tayo sa next topic natin. Yan. Diyan tayo sa Bernoulli trials at binomial distribution. Hindi tayo masyado mag-dig in sa Bernoulli trials. Doon tayo mag-focus sa binomial distribution. So, next. Yan. Una, i-discuss lang natin ng very, very light yung Bernoulli trials para ma-discuss natin yung binomial distribution. Yung Bernoulli trials, any eksperimento na may 2 possible outcomes, success and failure. At yung nag-experiment, yung nagde-define ng success or failure. Kunyari, ang success natin sa pag-roll ng dice is dapat makalabas ng even ng 3 at saka 6. So, parang multiple of 3s. Dapat, pag nag-roll ka ng dice, ang lalabas is multiple of 3s. So, ang success natin is 2 out of 6. Yung failure natin yung natira, yung hindi pasok doon sa probability na yun. Kaya kung makita natin, meron nakasabi dyan, P plus Q is equals to 1. Probability of success is P. So, 1 ay 2 all over 6. Tapos, Q is probability of failure. Yun naman yung natira. So, P plus Q magiging 100%. 100% na rin probability, which is 1. At na-discuss natin itong binomial distribution kasi mutually independent siya. Pag dinidiscuss natin yung probability of K successes or multiple success kapag merong multiple Bernoulli trials. Yan. At nakukuha natin ito sa pamamagitan ng equation dun sa baba. Yan. Combination of n, so combination of n trials within n trials in K successes times P, which is in success, to the power of K, times Q, yung fail, to the power of N minus K. Ayan. Ngayon, next tayo. Next slide. Yan. Usually, itong mga Bernoulli trials, ginagawa siya repeatedly. Ginagawa yung mga experiment na to repeatedly since dalawa lang yung possible outcomes nila as per definition. So, yung nagiging values nila, nag-range siya from 0 to infinite kasi nga pwede siya gawin multiple times. Okay. At dito papasok si binomial distribution. Si binomial distribution yung nagpapakita kung saan yung kung ano yung may pinakamataas na value or kung ano yung itsura ng distribution pagdating sa bawat part ng possibilities. Yan. At ginagamit to usually pag masyado ng mataas yung number of events or yung parang number of repetitions. Yan. At ninonotate natin siya gamit yung B within K and P. Yan. Probability of K successes in n independent Bernoulli trials. Tapos, probability of success, probability of failure, 1 minus P naman. Kaya, kung gagamitin natin yung kanina nating equation, ang kakalabasan is ito. B of K and P is equals to combination ng N and K times P to the power of K times Q to the power of N minus K. Yan. At dapat, pag sinimate natin lahat ng probability from 0 to N, ang kakalabasan dapat nila is 1. Kasi, since probability nga sila, lahat sila ay dapat maging 100%. Kasi nga, doon lang naman sila maghahati sa 100% ng probability. Yan. Try natin siya i-practice para mas maintindihan natin. Okay, next slide. Ayan. Ngayon, supposedly na nagko-coin flip ka, tapos biased yung coin flip for some reasons. Na lumalabas yung tails 90% of the time. So 0.9, may bias yung coin as tails. Samantalang yung heads lumalabas lang siya 0.1 or 10% of the time. Pero, syempre mutually independent yun. Hindi naman nila hindi sila nag-intersect or hindi sila kumukuha din sa isa't isa. Ngayon, ano yung probability na exactly 8 out of 10 ng flips ay tails? Yan. Saka natin ipa-plug in natin yung mga value dun sa equation natin. So, yung K, yun yung hinahanap natin na number of successes. At ayun ay 8 tails. Ngayon naman, pag N naman, yun yung number of attempts natin, which is 10 flips. Tapos yung P, yun yung success rate natin, which is yung 0.9. Ngayon, pag pinasok natin, combination of NK, usually pag ginagamit natin scientific calculator, NCR, or in this case, NCK. So, combination of 10 successes, ay 10 trials, and within 8 successes, times, P, or success rate, to the power of number of successes. So, 0.9 to the power of 8 times fail rate, which is yung 0.1, to the power of n minus k, which is yung fail, or n is 10, minus k is 8, so 2 naman. So, 0.1 to the power of 2. Pag ginawa natin yun, ang makukuha natin is 0.1937102,445, which is pag translate natin as chance, magiging meron tayong 19.37% na makakuha ng 8 tails mula sa 10 flips. Ngayon, dito papasok yung binomial distribution. Paano siya mag-a-appear sa lahat ng possibilities? Kunyari, hinahanap natin is 9 tails, o kaya 10 tails, o kaya 3 tails. Ano maging itsura? Next slide nga, please. Next slide po. Ayan. Ganyan yung naging itsura ng binomial distribution. Makikita natin na parating sa 10% is papunta sa 1. Usually, ganun yung binomial distribution. Pagdating sa 10%, lahat sila nagiging 1. Yan. Pero, nakikita natin na ang pinakamataas niya na point, maliban sa 10%, is si 9 tails. Since siya may pinakamalapit na outcome mula doon sa ratio natin or doon sa possibility of success, which is 0.9. So it will make sense. Pero kung for example, gamitin natin is 0.5, malaki yung pagbabago niya. Instead na si 9 successes yung magiging pinakamataas, ang mangyayari naman, magkakaroon siya ng pagtaas or rise dun mula sa 0.5, tapos throughout 0.5 pataas ng pataas na lang lahat sila. Ganon. Usually parang reverse exponential yung pagtaas nila. Yan. Yung sunod na i-discuss naman natin is random variable. Next slide po, and next presenter please.
Alright, so we're going to discuss the random variables now. Medyo madali lang naman tong part of the lesson. So medyo maintindihan itong in a very simple way. So, what is a random variable? It is a function of the sample space of an experiment to the set of real numbers. That means a random variable assigns a real number to the possible outcome. Let's say for example, next. Let's say for example, next slide. Okay. Let's say for example, Butchie want to toss a coin and see how many numbers of heads he could get. So usually makikita yung mga formula dyan is an x which is yung coin, and then the of t, yung outcome, is equals to k, yun yung number of heads. So let's say for example, we need to see kung ilang heads ang makukuha niya in one flip. Next slide please. So possible results ng isang heads o isang flip is head and tail. So our sample space would be h and t. So our random variable na ma-assign natin is like this. Next slide. So our random variable na usually display natin is x of h is equals to 1 and x of t is equal to 0. Since bakit 0 yung x of t? Kasi wala siyang number of heads. X of h, bakit 1 siya? Is because isa yung heads na pinakita. Let's say for example, we want to toss twice in a row. Like 2 coins. Next slide. Ayan. If we want to flip 2 heads, ang possible results natin would be heads, tails, heads, and tails. So our sample space would be HH, HT, TH, TE. So our random variable functions would be like this. Okay, next slide. Our random variable functions would be like this. Makikita natin na yun, xh is equals to 2, x of ht is equals to x of th equals siya sa 1. Kasi parehas silang isa yung heads. And then lastly, yung walang heads, which xpt is equal to 0. And lastly, if we want to toss it thrice in a row, like 3 times, we would have 8 outcomes. The next slide. We would have 8 outcomes na makikita natin, which is heads, 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 tails, heads, tails, heads, tails, heads, heads. At tapos yung mga nauna na yung mga tails, which is tails, 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 heads, tails, heads, tails, and head, tails, tails. So our sample space would be like that. Yung kung ano yung outcomes natin, medyo parehas lang din yung sa ating outcome. So our random variable functions will be displayed like this. Next slide. Ayan. Yan. So usually makikita natin mga random variable functions would be like this. xhhh is equals to 3 heads kasi siya. X of ht is equals to xhth, and so on and so forth is equals to 2 heads. And lastly, yung ating isang 1 head would be xtth, xtht, xhtt is equals to 1. And lastly, yung ating walang heads would be yung remaining outcome, which is the lahat tails. Now let's go to our next term, and that would be distribution of random variables. Ano naman yung distribution of random variables? It is a set of pairs of the sample space for all x where the probability p of x equals r is the probability that x takes the value of r. So yung x natin would be the number of heads. Yung x would be the number of heads, tama. X equals r will be the number of heads, and our p parenthesis would be the probability. Yun yung ating function. Let's go back to our example. Let's calculate all of the probabilities of these. Yan yung ating distribution of the number of heads. Yan. So meron nakasulat dito yung mga outcomes natin, and let's see kung ilan yung ating anong ang mga probabilities na mangyayari, like anong probability na magkakaroon tayo ng 3 heads, ano ulit magkakaroon ng probability na magkakaroon tayo ng 2 heads, ano naman probability na magkakaroon ng 1 head, and ano magkakaroon ng probability ng 0 head. So let's see. Next slide. Ayan. So yung probability of 3 heads would be 1/8. That's roughly 12.5. I think it's 12.5. Yeah, 12.5%. While the probability of having 2 heads and 1 heads is all equals to 3/8. That's roughly what? That's roughly 37.5%. And lastly, yung ating no heads, which is yung TTT, dapat ano pala yan, 0. Probability of 0 heads will also equal to 1/8. That's roughly 12.85%. So our distribution of random variable would be displayed like this. Next slide. Yan. So our distribution of the sample space X would be the pair of 3, 1/8, 2, 3/8, 1, 3/8, and 0, 1/8. Yan yung ating distribution of number of heads. Now let's go to the next term, which is the expected value of random variable. Next slide. Yan. It is a sum of the product of the probability of the element and the value of the random variable n at this element. Medyo hindi nakakaintindi yung description kung titignan nyo. Pero if we're just going to look at in a formula form, ganito maging itsura na. Next slide. Yan. Yan yung magiging itsura ng ating formula. So, di ba, yung sum yung R set of x sample space x is the sum of summation of that one would be like the product of the probability and the value ng ating heads or sample heads na yung toss coin natin. Yun yung ating expected value of random variable. Yung expected value of random variable, that will be the weighted average of the values of the random variable. Di ba, kung, for example, naka 5 tosses ako, dapat meron tayong weighted average nun kung ilang heads na makukuha natin every time in 5 tosses. Let's take an example from, okay, next slide. From the dices naman. Ay, hindi, never mind. Sige, yung ano pala yan. Coins pa rin pala yan. Okay, let's say what you want to toss a coin is the expected number of heads for 3 tosses. So, meron tayong mga functions ng random variables displayed here. So, we have 3 heads, 2 heads, 1 head, and 0 heads. And then, next slide please. Yan. So, our range would be the 3, 2, 1, and 0, where R is in the number of heads. And then, next slide. Yan. And also, we're going to get the probabilities of them happening. So, of course, yung ating 2 heads would have 3 over 8. The 1 head would have the 3 over 8. The 3 heads would have 1 over 8. And the 0 heads would have the 1 over 8 also. So, kung titignan natin yung ating formula kanina, it is sum of all element. It's a sum of the product of the probability and the value ng ating heads. So, therefore, ang mangyayari dyan would be like this. Next slide. Ayan, kinuha natin distribution of the sample space. And then next slide. Ayan. So ang ating makikitang formula dyan would be like this. The summation pa rin yan, parehas lang. So yung product natin would be the 3 of 1 over 8, 2 times 3 over 8, 1 times 3 over 8, and 0 times 1 over 8. So roughly that would be 3 times 3 eighths plus 6 eighths plus 3 eighths plus 0. So our expected number of heads done would be, next slide. Ayan. So our expected number of values then would be 3 over 2 or 1.5. So every time pa nagtotoss ka ng 3 coins, usually ang lalabas diyan is 1 over 1.5 heads. Bakit may 1.5 heads? It's actually an approximation. So it's a probability na meron tayong heads or tails sa ating middle element. So may shortcut kasi yan. You could take the middle element. So meron tayong kung discuss kanina yung normal distribution, makikita natin na parang para siyang mountain. So pag kukunin natin ng ating gitna, yun yung ating weighted average. So if we going to add them, usually ang lalabas lang dyan is 3 over 8 plus 3 over 8. So that would be 6 over 8. Pag dinivide natin sa 2 yan, it would also show the same. So that would be 3 over 2. Okay, next ano tayo? Now, let's go to the next term. And we're going to talk about the geometric distribution. Ano naman geometric distribution? Is to find the probability of the very first success of the number of trials. Let's say, for example, nag-toss tayo ng coin. And then, ang gusto ko mangyari is gusto ko magkakaroon ako ng tails sa fifth toss ko. So usually dapat ang mangyayari dyan would be tail dapat yung apat, and then on our fifth toss would be the tails. Yun yung geometric distribution. So if we're going to check the formula, it would show like this. Next slide. Yan. So our probability of that happening would be equals to the number of the failure probability raised to the number of trials minus 1 times the probability of success. Yun yung explanation ng ating formula dyan. We will go into use this formula para maintindihan natin on the next slide. Let's say, for example, we want to roll a dice. Yan. Next slide tayo. Yan. Rio wants to roll a 6-sided die several times until she gets 6. What's the probability of her getting her first 6 after 3 rolls? So our sample space would be 1, 2, 3, 4, and 5, and 6. Yun ating sample space. Ayan. So, kung mag-usually natin na ang mga probabilities na lalabas dyan would be 1 over 6. Kasi yung ating probability na makakuha tayo ng first 6 would, of course, 1 over 6. And the probability of failure, which is the 1 until 5, would be 5 over 6. Yun yung ating probability of failure naman. Usually, yung makikita natin would be Q. Tapos, yun yung discuss kanina, yung probability of failure equals to Q. So, next slide, please. Ayan. So, yung probability of getting a 6 would be P, and the probability of not getting a P is equals to 1 minus P. Yun yung siniscuss kanina, yung Q. Parang Q yun eh. Yung Q yata yun. Yung variable of Q. So, kung 1 over 6 yung makukuha natin first, yung ating 6. And then, kung kukunin natin yung probability of failure na would be minus 1 minus 1 over 6. That would be 5 over 6 yung ating probability of failure. The sample space would be XX6. Bakit naman XX yan? Yung XX is a random number except number 6. And then the trials would be number K. So next slide, please. Ayan. Ayan, so yan yung magiging usually ating formula, yung ating mga variables. Yung P would be 1 over 6. Yung Q natin would be 5 over 6 kasi 1 minus 1 over 6. Our sample space would be XX6, and our 3 would be, our trials or K would equals to 3. Now, let's go to the solution. Next slide. Ayan. Let's go to the solution. So, our probability of getting, of 3 trials, tapos our first 6 would be the third roll. So usually ganyan mangyayari. Bakit 3 minus 1? Remember, we're going to have the first 6, yung third roll natin as 6. Tapos yung ating first and second would be probability of loss. Kaya ganyan siya. Ayan. So magiging 1 minus 1 over 6 raised to 3 minus 1 multiplied by 1 over 6. So our probability of that happening would be, next slide. Yan. Would be 0.1157 or 11.57% roughly. Yan yung ating solution. Next slide. Since we're done with the geometric distribution, we're now going to the final topic I'm going to discuss, which is the independent random variable. What is independent random variable? It is when two random variables on the sample space are independent. Of course, why would you say that? It is to know that if one changes, the probability of both together will change. So for example, if we're going to toss two coins, kung papalitan natin yung isang coin, it won't change the probability na mangyayari yung situation na yun. Now let's go to the example para medyo natin ma-visualize. Ayan, ito pala yung formula, my bad. So, ang ating formula dyan would be the probability of x equals r and y equals r2, and equals siya kapag multiply silang dalawa. So yun. May visualize natin yan, makikita natin yan sa kapag nag-roll tayo ng dice. Next slide. Ayan. Let's say we want to roll two six-sided die this time, sabi ni Rio. See if this is an independent random variable. So our sample space would be like this. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Hindi ko na papasahin yan. Ang dami nan. So, kasi 36 yun. Hanggang maging 6, 4, 6, 5, and 6, 6. That would be our sample space. Now, let's see kung anong gagawin natin. Yan. If we roll two six-sided die together, each of them happening would have 1/36. So for instance, if I roll 2 and 4, that's roughly 1/36. Kung nag-roll naman ako ng die na 1 and 6, that's also 1/36. Yung I over j, that would be the number of sides ng ating dices. Kaya, yan, x equals to 2, yun sinabi ko kanina, and y is equals to 6. Yun yung ating dices. Now, if we're going to check the probability of each die naman, that would be 1/6. And then our second die, which is the probability of y equals j, that's also roughly to 1/6. So if we're going to multiply them together, next slide. Okay, next slide pa. Yeah, if you're going to multiply them together, so that would be equals to 1/36 yung union ng ating dalawang dices, and the multiplication ng ating two dices, so it is 1/6 times 1/6. So that would roughly equal to also 1/36 then. So next slide. We have proved that 1/36 equals to 1/36. Therefore, they are both independent. Now that we have discussed the random variables and until independent variables, we will now move on to the next topic, which is the algorithms.
Okay.
So, am I audible po?
Yes.
So, ang next po is Monte Carlo algorithm. So, what is Monte Carlo algorithms? Monte Carlo is a technique used to understand the impact of risk and uncertainty. It is used to calculate the probability of different outcomes in a process that cannot easily be predicted due to the intervention of random variables. So, it is a test of probability and iterations. So, basically, ayan yung Monte Carlo. Next slide. So, Monte Carlo algorithms refers to the Grand Casino in the Principality of Monaco at Monte Carlo, which is well known around the world as an icon of gambling. Monte Carlo uses randomness just like slot machines, dices, and roulette wheels. Next. A Monte Carlo algorithm uses a sequence of tests. The probability that the algorithm answers the decision problem correctly increases as more tests are carried out.
Monte Carlo focuses on constantly repeating random samples. The Monte Carlo uses multiple values and then averages the result. So, Monte Carlo methods or Monte Carlo experiments are a broad class of computational algorithms that rely on repeated random sampling to obtain the numerical results. The underlying concept is to use randomness to solve problems that might be deterministic in principle. They are often used in physical and mathematical problems and are most useful when it is difficult or impossible to use other approaches. Next slide. So at each step of the algorithm, possible responses are true, which means that the answer is true and no additional iterations are needed, or unknown, which means that the answer could be either true or false. After running all the iterations in such an algorithm, the final answer produced is true. If at least one iteration yields the answer true, and the answer is false, if every iteration yields the answer unknown. If the correct answer is false, then the algorithm answers false because every iteration will yield unknown. So, basically, parang sinasabi niya lang, if nag-iterate ka and mostly yung test is lumabas is true, then it will conclude that the result is true and the same as false kung every iteration is false. So, however, if the correct answer is true, then the algorithm could answer either true or false because it may be possible that each iteration produced the response unknown, even though the correct response was true. We will show you that this possibility becomes extremely unlikely as the number of tests increases. So, ang sinasabi dito is, since nag-iterate ka, pwedeng lumabas is true or false. So, kahit na mostly ang sagot is true, meron pa ring false. So, it is not correctly 100%. So, this will, ang sinasabi rin dito, the possibility becomes extremely unlikely as the number of tests increases. So, mas maganda kapag maraming tests ang ginawa mo. So, next slide. So here are the popular tests of Monte Carlo. So quality control and probabilistic primality testing. So quality control. This test determines if the random variable satisfies the condition whether it is true or false. Probabilistic primality testing. This test takes a natural number as input and attempts to determine whether that number is prime or composite. Next slide. So, sa quality control muna tayo. So, example, suppose that a manufacturer orders processor chips in batch of size n, where n is a positive integer. The chip maker has tested only some of these batches to make sure that all the chips in the batch are good. The PC manufacturer wants to decide whether all the chips in a batch are good. To do this, the PC manufacturer can test each chip in a batch to see whether it is good. However, this requires n tests. Can the PC manufacturer determine whether a batch of chips has been tested by the chip maker using less time? So next slide. So it proceeds by successively selecting chips at random from the batch and testing them one by one. When a bad chip is encountered, the algorithm answers true and stops. If a tested chip is good, the algorithm answers unknown and goes on to the next chip. After the algorithm, so next slide please. So, ayan. So, for example, nag-test tayo ng 20 chips. Next slide ulit. So, after the algorithm has tested a specified number of chips, says, 20 chips nga. So, without getting an answer of true, the algorithm terminates with the answer false. That is, the algorithm concludes that the batch is good, that is, the chip maker has tested all the chips in the batch. So next slide. So ayan, as you can see, mark yung mga true and mark yung false. So mas marami yung false, so magko-conclude siya as false, which is next slide. So which concludes that the batch is good or the batch has been tested. Next slide ulit. So next naman is probabilistic primality testing. This observation is the basis for a Monte Carlo algorithm to determine whether an integer greater than 1 is prime, because large primes play an essential role in public key cryptography. Being able to generate large primes quickly has become extremely important. Next slide. So yung probabilistic primality testing, basically tinetest niya if a number is prime or composite. So the common approach to this problem is a simple brute force solution. That is, divide the number by every integer from 2 and check the remainder. This is certainly the easiest way to solve the problem. So, halos lahat naman siguro familiar dito sa modulo na to. If chine-check niya if a number is prime or composite. And next slide. So, since we're dealing with Monte Carlo algorithms and it is about probability and iteration, so we'll use prime pa rin na modulo para ma-test if a number is prime or not. But it is through iteration. So there are numbers of different probabilistic primality tests, some better than others. One of more simple probabilistic primality tests is the Fermat primality test, which is based on Fermat's little theorem and is used in PGP and RSA encryption. The theorem states that if P is prime, then A raised to P minus 1 is equivalent to 1 multiplied by modulo of P, where A is greater than or equal to 1 but less than P. So ayan, as you can see in the code, bale mag-generate ka ng random object and then yung A is a random integer, then yung P is yung number mo, which is yung kung itetest mo kung prime or not. So it is all about, since random yung A, magiging probability if ang kakalabasan niya is true or false. So ayun, next slide. Since random nga yung A, maglalagay tayo ng for loop para maging magkaroon tayo ng iteration. So this method will indicate if P is a probable prime, but since we're only selecting a single value A value, the possibility of P being incorrectly identified as a prime is high. In such situation, A is referred to as a Fermat line. As suggested earlier, we can minimize this probability by repeating the process K times expecting K witnesses. So this allows us to improve the probability of correctly determining the primality of P by performing K iterations, in which the probability of error becomes vanishingly small for large values of K. So next. To generate large primes, say with 200 digits, we randomly choose an integer n with 200 digits and run this algorithm with 30 iterations. If the algorithm decides that n is prime, we can use it as one of the two primes used in an encryption key for the RSA crypto system. If n is actually composite and is used as part of the key, the procedures used to decrypt messages will not produce the original encrypted message. The key is then discarded and two new possible primes are used. Next. Chapter 7, Expected Value and Variance. Next slide. So, since kanina nga is na-discuss na ni Jen yung expected value and random variable kanina. So, magpo-proceed na tayo sa variance. So, the variance of a random variable helps us characterize how widely a random variable is distributed. In particular, it provides a measure of how widely X is distributed about its expected value. Next slide. So, let X be a random variable on a sample space S. The variance of X denoted by variance of X is, ayan. So, as you can see in the formula, variance of X is equal to summation of X of S minus summation of X all squared times the probability of S. So, that is, variance of X is the weighted average of the square of the deviation of X. The standard deviation of X denoted deviation of X is defined to be square root of variance of X. Next slide. So, variance of a random variable X is expected value of the square of the difference between X and its own expected value. This is commonly expressed as saying that the variance of X is the mean of the square of its deviation. We also say that standard deviation of X is the square root of the mean of the square of its deviation, often read as the root mean square of the deviation. Next. So, ayang nakikita nyong formula na yan, ayun yung standard deviation. Pero since ang tinatakan natin is variance, so, ang variance is yung squared lang nung standard deviation. So, tatanggalin mo lang square root nung standard deviation. Next. So, example, to solve for variance, what is the variance of the random variable x of I and j is equals to 2i, where I is the number of appearing on the first die and j is the number appearing on the second die when two paired dice are rolled. So, next. So to solve the problem, we will use this formula. Variance of X is equals to summation of each X squared minus EX squared. So, next. To do so, we need to find the expected values of X and X squared. So since die siya, meron siyang 6 possible outcomes. So, since yung problem natin is X of I and J is equals to 2i, yung 2i, yung I natin is yung number of outcomes ng die. So, 1, 2, 3, 4, 5, 6. So, 2i, 2, and 2, 2, 4, and so on. Hanggang maging 2, 4, 6, 8, 10, 12. So, divided by 6, which is the sample space, is equal to 7. So, next. So, next naman is naka-squared yung each variable. So, 2 squared plus 4 squared plus 6 squared plus 8 squared plus 10 squared plus 12 squared. Divided by 6, so is equals to 182 over 3. So, next. So, going back nga dun sa formula, which is yung E and squared nung each variable minus E of X squared. So, ayan. It follows that yung 7 natin, which is yung E of X, is squared lang natin. And then yung 182 over 3, same lang siya. So, ibababa lang natin. So, 182 over 3 minus 49 is equals to 35 over 3. So, going back to the problem, the variance of the random variable X, I, and J is equals to 2i, where I is the number appearing on the first die and J is the number appearing on the second die when two paired dice are rolled, is 35 over 3. So, ayun yung variance niya. So, next slide. So ngayon naman, we'll go back to icebreaker muna tayo. Ang magpa-facilitate ng icebreaker natin is si Jen. So, Jen.
Alright, sige, let's start.
Peace.
We just need 2 volunteers. Madali lang naman tong game na to, which is Prince Balls. Usually ginagamit tong game na to sa programming interviews, pero explain ko na rin din yung rules ng game. Madali lang naman. So basically, you're going to count from 1 to infinity and so on and so forth. But there's a catch. Kapag multiple siya by 3, dapat sabihin nyo fizz. And then kapag multiple siya by 5, you need to say buzz. So kapag, for example, salit-salitan kayo, so 1, 2, tapos sa kabila, since 3 is a multiple of 3, therefore going to say fizz instead of saying 3. And then, tuloy-tuloy yun. So 4, buzz, 5, fizz, 7, 8, fizz, hanggang sa ano. And then kapag multiple siya by 3 and 5, that would be fizz buzz. Parehas sila dapat. So, fizz buzz. So, kapag 15 yung sinabi mo, dapat sabihin mo fizz buzz. Yun lang siya. Ganun lang yung mechanics ng game. Paano kapag nagkamali? Dapat malaman dapat mapansin ng kalaban mo na may mali. Therefore, siya yung mananalo. So, we need, ilang volunteers ba kailangan? We need 2 volunteers na ba? Adrian?
Yes, 2 volunteers lang.
2 volunteers lang. Alright, sino gustong mag-volunteer? And in total to, no, 2 volunteers lang talaga.
I-volunteer nyo na sila.
Sige. Pili nga kayo. Ano gusto nyo? Adrian, ikaw nga pumili. Ano mo ito ba? Ano? Kailan, tignan ko yung nasa ano. Ano ba? Review. Yan. Pili ka kayo. Pili kayo. Ano gusto niyo? May nag-volunteer daw si President na ulit.
Pasaway ka. Pero sige, go lang.
Sige.
Si gusto kong kalaban si Pau.
Si Pau. Sige, Pau daw.
Si Paolo. Ano si Paolo?
Paulo, nasan daw?
Special request, Paolo.
Ako, nahila.
Hello?
Ayan. Madali lang naman to. Best of 3 to So, di bale, kapag may tiebreaker to kapag 1-1.
Okay.
Wait lang, so bale pag 3, fizz, tapos pag 5, buzz. Tama ba?
Tapos pag multiple siya ng both, for example, 15, fizz buzz. Ganun. So, dapat
ulit? Sorry? Kapag
pag multiple siya by 3, kailangan mo sabihin fizz. Pag multiple siya by 5, you need to say buzz. And
fizz,
then kapag
buzz?
Fizz, tapos buzz.
Fizz.
Tama. Fizz, tapos buzz.
Ha?
And then
fizz?
Fizz, yun ang nakasulat sa PowerPoint.
Fizz buzz, sorry.
Fizz buzz, nasa PowerPoint. And then kapag multiple siya by both, for example, 15,
fizz buzz.
Fizz buzz, So, salit-salitan kayo. Sino mauna?
Si Pau.
Si Rachel muna.
Alam mo yan, ikaw na, Pau. Mauna ka. Please, game. Mauna ka.
Ako mauna?
Oo.
Okay.
Sige,
Game.
let's go.
Game.
Ano to? Yung
Asa
simula
na?
na. Ikaw, 1. Magsimula
Magbibilang
ka
ka,
sa
1 ka.
1.
2,
Fizz.
4,
Buzz.
fizz,
7.
8.
Fizz.
Buzz.
11.
Fizz.
13.
14.
Fizz Buzz.
16.
17.
Fizz.
19.
Siguro eh.
Buzz.
Fizz. Sorry.
Hindi ko nag-iisip pa
22.
eh.
Ha?
22.
23.
Fizz.
Buzz.
Anong number na tayo?
Sige.
Wait, 26. 26. Ay, meron ba?
26.
Fizz.
Wait. 28.
29.
Fizz Buzz.
31.
32.
Fizz.
34.
Fizz Buzz. Ay!
Mali. Okay, nanalo si Rachel. So, tuloy tayo sa 35. Dire-diretso na yan.
Ako?
Ikaw na. 36.
Okay. Wait lang.
That's Buzz dapat, diba? Ay,
Fizz. 36, diba? Fizz. Okay, go. Ikaw na pa.
37.
38.
Fizz.
Buzz.
41.
42.
Mali!
Okay.
Oo
42 is a
nga,
multiple of 3. Alright. Sige, okay. Tiebreaker. From 42 tayo. Then, so magsisimula ka 43, Paolo.
Okay, 43.
Okay.
44.
Nagdo-double check
Fizz
pa eh. Tama. Okay.
46.
47.
Fizz.
Tama.
49.
Buzz.
51.
Mali.
Mali ba?
Mali.
3, 6, 9, 12, 15, 18. Okay.
Okay.
Alright, so Rachel yun na yung nanalo doon sa ating game. So, hintay na lang sa surprise namin. Makikita niyo naman mamaya.
Mag-expect ako ha.
Mag-expect ka promise.
Yes, ha?
Oo, mag-expect ka promise. True yan.
Okay na.
Alright, okay na. Thank you for participating for the icebreaker. So usually, ang game na yan is usually interviewed sa mga programming interviews. So we're going to use for loop there and then just if else to display the kung multiple siya ng 3 or 5. Okay, let's go to the next topic na. Sino na yung mag-discuss?
So, ang i-discuss naman natin ngayon is advanced counting technique. So, what is recurrence relation? A recurrence relation occurs when some number in a sequence depends on the previous number. So, a good example is the Fibonacci sequence. The initial condition for a recurrence relation, the values of the terms of a sequence satisfying the recurrence relation before this relation takes effect. So, let's have Fibonacci sequence as our first example. A Fibonacci sequence is a series of numbers in which each number is the sum of the two preceding numbers. So we start off with 1 and the next number in the sequence is always going to be the previous two added together. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, so on and so forth. So that's the counting sequence. More formally, we can define the nth number an to be equal to the sum of the two previous numbers. So we can say this is a sub n minus 1 plus a sub n minus 2. Commonly, you'll see this with Fibonacci sequence written fn is equal to fn minus 1 plus fn minus 2. So the n term should be n minus 1 term and the n minus 2 terms added together. That means a sub n is equals to a sub n minus 1 plus a sub n minus 2. So we're going 2 terms back, which means we need to initial conditions. So we also need to define that a sub 1 is equals to a sub 1, a sub 2 equals 1, because those are the first 2 terms of the Fibonacci sequence, and that is how you find the recurrence relation of Fibonacci sequence. Another example is the Tower of Hanoi, which is a classic problem, a popular puzzle of the late 19th century invented by the French mathematician Edward Lucas. The Tower of Hanoi consists of 3 pegs mounted on the board, together with a disk of different on the first peg in order size, which with the largest on the bottom. The rules is the puzzle allows the disk to move one at a time from one peg to another, as long as a disk is never placed on the top of the smaller disk. The goal of the puzzle is to have all the disks on the second peg in order size, with the largest on the bottom. How it works. There can be a number of disks on source peg. Let's trace the problem for n equals 3 disks. Let h sub n denote the number of the moves needed to solve the Tower Hanoi puzzle with n disks. The trace of the solution is step 1. Move the disk C from the source peg to the destination peg. Step 2. Move disk B from the source peg to the auxiliary peg. Step 3. Move disk C from the destination peg to the auxiliary peg. Step 4. Move the disk A from the source peg to the destination peg. Step 5. Move disk C from the auxiliary peg to the source peg. Step 6. Move disk D from the auxiliary peg to the destination peg. Step 7. Move disk C from the source peg to the destination peg. Begin with n disk on peg 1. We can transfer the top n-1 disk following the rules of the puzzle to the peg using h sub n-1 moves, katulad nung sa step 2. We keep the largest disk fixed during this move. Then, we use one move to transfer the largest disk to the second peg. Finally, we transfer the n-1 disk on peg 3 to peg 2 using h sub n-1 moves, placing them on the top of the largest disk, which always stays fixed on the bottom of the peg 2. This shows that we can solve the Tower Hanoi puzzle for n disks using 2h sub n-1 plus moves. We now show that we cannot solve the puzzle for n disks using fewer than 2h sub n-1 plus 1 moves. Note that when we move the largest disk, we must already have moved the n-1 smaller disk onto the peg other than peg 1. We can conclude that h sub 1 equals 2h sub n minus 1 plus 1. The initial condition is h sub 1 equals 1 because one disk can be transferred from one peg to peg 2 according to the rules of the puzzle in one move. Now, let's discuss the solving linear recurrence relation. A wide variety of recurrence relation occurs in models. Some of the recurrence relation can be solved using iteration or some other ad hoc technique. However, one important class of recurrence relation can be explicitly solved in systematic way. This recurrence relation that express the terms of a sequence as linear combination of the previous terms. So let's discuss linear homogeneous recurrence relation with constant coefficient. Our recurrence relation is called linear if its degree is 1. The general form of linear recurrence relation with constant coefficient is a sub n equals C sub 1 A sub n minus 1 plus C sub 2 A sub n minus 2 up to C sub k A plus A sub n minus k, where C sub 1, C sub 2 up to C sub k are real numbers and C sub k is not 0, because if C sub k is 0, that means the order will change. The recurrence relation is defined is linear because the right-hand side is a sum of previous terms of the sequence, each multiplied by a function of n. The recurrence relation is homogeneous because no terms occur that are not multiplied of the A sub js. The coefficients of the terms of this sequence are all constant, rather than functions that depend on n. The degree is k, A sub n is expressed in terms of the previous three terms of the sequence. A consequence of the second principle of mathematical induction is the sequence satisfying the recurrence relation in the definition is uniquely determined by the recurrence relation and the phase initial condition. So let's have an example para makita niyo yung pinagkaiba ng linear homogeneous and not linear homogeneous. So nakikita niyo sa screen lahat yan example ng linear homogeneous with constant coefficient. Katulad nung Pn equals 1.11 P sub n minus 1 is a constant coefficient and degree 1 siya. Yung pangalawa naman is Fibonacci sequence which is degree 2. Malalaman nyo kung anong degree siya dito sa dulo, dun sa sub niya. And yung pangatlo naman is A sub n equals A sub n minus 5. The highest number you subtract from the n on the right hand side is basically the degree. Kaya sa degree 5. Halimbawa naman ng not linear homogeneous with constant coefficient, yung una hindi linear dahil sa A sub dahil dun sa in-squared niya yung A sub n minus 2. Kasi hindi mo pwede i-squared ang isang term. Yung pangalawa naman is hindi linear homogeneous dahil sa plus 1. Homogeneous means only one term of the sequence are involved. And yung last one would be linear kasi hindi constant coefficient dahil dun sa n before ng B sub n minus 1. To solve a linear homogeneous recurrence, assume a solution from the form A sub n equals P to the n. We're gonna solve the recurrence A sub n is equal to A sub n minus 1 plus 2A sub n minus 2, where the zero term is 2 and the first term is 7. If A sub n equals to the P, that means we have P to the n is equals to the 3 to the n minus 1 plus 2 to the n minus 2. Now, gagawin natin is i-remove natin yung common factors. Remember yung algebra natin, ang effective na gawin is divide both sides by the lower power of c, which means in this case is n minus 2. I-assume natin na c is not equals to 0. If it equals to 0, this would not be interesting at all. We would get a n equals to 0 and magiging sequence lang siya ng 0. But dito sa case na to, i-assume natin na 0. So, n over n by the something to the n minus 2. We get 2 powers left over. N minus 1 over n minus 2 would be p to the first and p to the n minus 2 over p to the n minus 2 would be 2. Makikita nyo, may quadratic tayo na isi-solve. So this means we have p squared minus p minus 2 equals 0. Which means p minus 2 times p plus 1 equals 0. Which means p equals 2 and p equals negative 1. Okay. Remember that the solution was assumed to have a form a sub n equals to t to the n. Our solution has the form of a sub n is equals to some constant 2 to the n plus some other constant times negative 1 to the n. Ito. So the goal becomes finding a and b, which we can find because of our initial condition, which where here term is 2 and the first term is 7. So we note that a sub 0 is times 2 to the 0 plus b times negative 1 to the 0, which was supposed to be equal to 2. Okay. Let's simplify the equation. That gives us the equation a plus b equals to 2. Next is a sub 1 is equals to capital A times 2 to the first plus capital B times negative 1 to the first, and that's supposed to give us 7. So this means we have 2a minus b is equals to 7. So we can solve that either elimination, substitution, but ang gagawin ko is to add the equation together. Let's give ito. That gives us 3a equals 9, which means a equals 3, and if a equals 3, and in this equation, that means b is equals to negative 1. This means that a sub n is equals to 3 times 2 to the n plus negative 1 times negative 1 to the n. Kung isi-simplify natin siya, ang mangyayari is a sub n equals 3 times 2 to the n plus negative 1 to the n plus 1. That expression right there will tell us what term is after that. So instead of using recurrence, we can use this formula. So, i-discuss naman po ni Mark yung linear non-homogeneous recurrence relation with constant coefficients.
Ako po yung magsagot sa mga last term po. Sa linear non-homogeneous recurrence relations with constant coefficients are recurrent relation that equates the terms when system for initial terms of the linear combination of previous terms plus a function that is not identically structured. That depends on the next equation. Consider the linear non-homogeneous recurrence relation a sub n equals to 2a sub n minus 1 plus 3a sub n minus 2 plus 5, where n greater than equal to 2 and initial values of a sub 0 equals 2 and a sub 1 equals 3. Step 1. Find the characteristic equation. The characteristic equation is r raised to 2 minus 2 or minus 3 equals to 0. Step 2. Solve for the root of the characteristic equation. We can use quadratic formula. R equals to negative b plus minus square root of b raised to 2 minus 4ac all over 2a, where a is equals to 1, b equals to negative 2, 3 is equals to 50. Therefore, the root of the characteristic equation are r1 equals to 3, r2 equals to negative. Write the general solution of the homogeneous equation. The general solution for the homogeneous equation is a sub n equals to c1 times e to n plus e times negative 1 raised to n. Step 4. Find the particular solution. Since the non-homogeneous term is a constant, we can use the method of the undetermined coefficient. Particular solution will have the same as the non-homogeneous term. So we can write a sub n equals C3 times n plus C4. Step 6. Substitute the initial value and solve for C1, C2, C3. We have two equations. This equals to C1 plus C2 plus C3 plus C4 equals to n. A sub 1 equals to 3C1 minus 3C1 minus C2 plus 3C3 plus 2. Solving for coefficient, we get C1 equals to 2, C2 equals to 0, C3 equals to negative 2, C4 equals to 0. C4 is equal to 8. Step 6. Write the general solution for the non-homogeneous equation. The general solution for the non-homogeneous equation is equals to 2 times 3 raised to n minus 2n plus 2. Therefore, the solution for the linear non-homogeneous recurrence relation is sub n equals to 2 times 3 raised to n minus 2 plus 2. And right. The next thing that I will discuss is the divide and conquer an algorithm that solves a problem recursively by splitting it into a fixed number of smaller non-overlapping sub-problems of the same type. So, nag-read out ng dalawang madalas gamitin sa program and ito na method ng divide and conquer algorithm. Una-una na dyan is yung divide of f of 8 divide and conquer algorithm. Step 1. Divide the problem into sub-problems. It equals to f of 8 divide 2 plus 2 equals to f of 4 plus 2. Step 2. Solve the sub-problem. F of 4 equals to f of 4 divide 2 plus 2 equals to f of 2 plus 2. 2 f of equals to f of 2 divide 2 plus 2 equals to f of 1 plus 2. Step 3. The solution of 1 equals to f of 2 divide 2 plus 2 equals 0.5 plus 2. Note, this is not a valid input as the f of n should only be a positive integer. F of 8 equals to f of 4 plus 2 equals plus 2 equals to f of 1 plus 2 plus 2 plus 2 equals to 4. Therefore, value of f of 8 equals to using the dividing and conquer algorithm like in pineapple. Next slide. Yung naman na-read yung third step data. The divide and conquer relation is measured and be represented if n 2t 2t of n by 2 plus o of n, where t of n is the time complexity of certain array of type n. 2t of n minus 2t of n divided by the time of complexity of the array. Let's start the job. And O of n represent today time complexity of merging sorted halves 1. Let's say we have an array of type is consists of 5, 4, 7, 2, 1, 3. Step 1. Divide the array into two halves, which is kinuha natin yung first half, this is yung 5, 4, 7, 2. Yung second half naman, 6, 1, 3, 8. Next slide. Step 2. Each half of each sort each use this front. Write the first 5 and 2. First started, ano na natin, kinumpay natin yung dalawang half into 1. And naka-form tayo 2, 4, 7. Repeat the process for the second half. So, natirang mga numbers dun sa may second half, i-sinort din natin, which is naging 1, 3, 1, 3, 8. And third step, the time complexity of sorting the array of size 8 can be represented by the divide and number recurrence relation. If 2t of 4 plus O of 8 equals 2 times t of 2 plus O or plus O of 8 equals to 2 times 2 t of 1 plus O of plus O of 4 plus O. Times O of 2 of 1 plus 2 of 2 plus 2 plus 8 equals to O. Sorry. Next slide. So, yung next naman na term na i-discuss din, it's about naman sa generating function of A. Form a series of T and term of the sequence as the coefficient x raised to n. Let's say we have sequence 1, 2, 4, 8, 16, 32, which represents the powers of 2. We can represent this sequence using the generating function of power f equals to 1 plus 2x plus 4x plus 4x raised to 4 plus 3. Generate information in terms of the sequence. Each term in the sequence represented of sequence coefficient 2x plus 1 in the generating function. The generating function to analyze the properties of the sequence and make calculations such as finding the sum of the first n or the nth term of the sequence. For example, to find the sum of the first n of the sequence, we can substitute x equals to 1 to the generating function. F of 1 equals to 1 plus times 1 plus 4 times 1 raised to 2 plus 8 times 1 raised to 2 plus 16 times plus 16 times 1 raised to 5 and so on equals 1 plus 2 plus 4 plus 8 plus 16 plus 32 and so on. This gives the sum of the first n terms of the sequence.
Oh,
Consider
wait lang.
1, 2,
Wait lang. Asan na yung ating reminder? Asan si, Sino yung taga-remind natin? Yes! Micah.
Ma'am, pwede.
Anong i-remind mo, Micah?
Time na po.
Yun.
Pwede po, extend na lang kasi malapit na rin po matapos, onti na lang po yung slide eh.
O, ayan, nag-request. Micah, okay lang ba?
Last first slide na lang po after na itong generating of
Sige,
function.
tapusin mo na. Sige, para
Okay lang.
tapos ka na.
Okay. Example 2. Consider the sequence consists of 1, 2, 4, 8, 16. Solution. Generating function for this sequence is given by f of x plus 1 plus 2x plus 4x raised to 2 plus 8x raised to 3 plus 16x raised to 4 and so on. The generating term of the sequence can be obtained from the coefficient of x of in the generating function. For example, the fourth term n equals to 4 is in the sequence is given by the coefficient of x raised to 4, which is 16. Next slide.
Ito na yung last slide.
Last. And yung last na, ay, yung last, pang second to the last term na i-discuss with you is yung sieve of Eratosthenes. A procedure for finding the primes less than specified positive integer. Example, the sieve of Eratosthenes can be expressed by adding a step 4, which is used to calculate the number of prime numbers n in a given range. This step is known as the counting step, or the n is to p prime sub 1, p prime sub 2, p prime sub 3, p prime sub 4 step. Here's how the counting step works. Count the number of prime numbers in the given range, p prime sub 1, p prime sub 2, p prime sub 3, p prime sub 4, by subtracting the index of the first prime number from the index of the last prime number, n equals to prime sub 4 minus prime sub 1 plus 1, wherein prime sub 1 is the index of the first prime number in the range of prime sub 4 is the index of the prime number in the range. Next slide, please. Let's say we have a list of prime numbers up to 30, and we want to find the numbers of primes between 10 and 20. So, nilist natin yung mga prime numbers from 1 to 30, which is 1, 3, 5, 7, 11, 13, 17, 19, 23, and 29. The index of the first prime number in the range 10 is 4, and the index of the last prime number in the range 20 is 7. Number of 10 and 20, 7 minus 4 plus 1 equals 4. So, sum of p prime sub 1, p prime sub 2, p prime sub 3, p prime sub 4 is 4, which means there are 4 numbers between 10 and 20. Okay. So the last term that I will discuss is the range. The arrangement is a permutation of objects such that no object is in its result. Example 1. How many ways can the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 be arranged so that no even digit is in its original position? In this case, there are 10 even digits, 0, 2, 4, 8, and 5. The number of arrangements of the 10. This can be calculated using the formula of arrangement, which is n equals to n factorial times 1 minus 1 divide 1 factorial plus 1 divide 2 factorial minus 1 divide 3 factorial, and so on until we reach negative 1 raised to n divide n factorial. Next. Plugging in n equals to 5 for the numbers of even digits, we have b of 5 equals 5 factorial times 1 minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial plus negative 1 raised to 5 divide 5 factorial equals to 120 times 1 plus 1 half plus 1 and plus 1 over 120. So 120 times 1 over 120 equals to 120 over 120 equals to 1. So there is only one the arrangement of the 5 even digits, since the 5 even digits can be paired with any of 5 digits 1, 3, 5, 7, and 9. And there are 5 factorial times 1 equals to 120 possible arrangement of the all 10 digits with even no digit in its original position. And that's the end of the presentation. Thank you for listening.
Ayun. O, diba? Natapos din. Okay. So, meron pang babalikan yung group, Group 4? Or that's the end? Kasi diba there are 2 chapters. Teka. 2 chapters. Yeah, ito. So, discrete probability and advanced counting techniques. So, na-cover na ba yung ano? Yung pang 8 na chapter?
Yes po, ma'am. All, ano po.
Hanggang doon sa dulo. Okay. The next meeting ay group 5. Okay, class, dun sa ating attendance, pakilagay po yung last na topic, which is, para sa attendance natin, dun sa topic is Chapter 8, Advanced Counting Techniques. Ayan, ha? Tapos, meron akong mga inilagay na para sa Python natin, kasi diba ina-align natin yung ating Python at saka itong topic natin sa Discrete Structure 2. So, may mga projects doon na pwede nyong sampulan, no? Yun sa Monte Carlo. I think we did this also beforehand, pero may ibang version, no? Na mga project with Monte Carlo algorithm, no? Okay. So, sige. Doon na tayo mag-end. Ibig sabihin, next meeting, it would be chapter 5, chapter 9 and 10, which will be covered by group 5. Ayan, no? So, inalign na natin. Okay. So, balikan natin dito sa ano to eh, sa site ako ngayon nag-ano. Okay. So, thank you. Thank you for coming today. Ayan. So, i-end ko lang by showing yung ating attendance. Okay, 30. So, Rachel, ilan ang kulang pa natin doon sa 30?
6 po, ma'am. 36
So,
po lang.
meron tayong 6 na absent ngayon. Okay. Na wala. Okay. So, sige, doon na tayo mag-end. At i-end ko na rin yung ating recording. Ayan. So, meron po ba kayong question dito sa present